Factorizing quadratic expressions using the array model. We're going to look at 4 examples in this video. So we're asked to factorize the quadratic expression 3x squared plus 10x plus 8. I'm going to create the quadratic array with the 4 boxes like this. We know from multiplying out binomials that in the first box we put the 3x squared, the squared term, and the final box, the opposite corner, comes the constant, that's the plus the 8. If we multiply the two of these together, we get 24x squared. That's 3x squared multiplied by 8. And that should be the same as the multiple of the other diagonals. Both diagonals multiplied give you the same thing. But we know in the missing diagonal, the one we're looking for, we know it must add up to 10x. So we're thinking of what two numbers that when we multiply them give 24x squared, but when we add them give 10x squared. Well, we could think of factors of 24x squared, like 3x by 8x. But this does not work because if we add it, it gives us 11x. We want it to give us 10x. So we think of another one. So maybe 4x by 6x. We see this is correct because when we multiply it, we get 24x squared. But when we add it, we get 10x. It makes no difference where we place the 4x or the 6x into the quadratic grid. We see there's a common factor in the top row. X by 3x gives us 3x squared, and x by 4x gives us plus 4. 4 goes into 8 2 times, and we'd also see that two groups of 3x is 6x, so we see that this is correct. So in other words, we could write 3x squared plus 10x in factorized form as 3x plus 4 by x plus 2. So this is our solution. Let's look at a few more examples. So we're asked to find the factors of 2x squared minus 11x plus 12. We're going to draw the quadratic grid. In the first box we place the 2x squared, the squared term. In the last box we place the plus 12. When we multiply this diagonal we get 24x squared. This would be the same as multiplying the other diagonal. So the multiple of the diagonal is 24x squared. The missing diagonal we know adds up to negative 11x. So we're thinking factors of 24x squared that when we add them gives us 11x. We know that these must be two negatives to get a negative. So it would be negative 3x by negative 8x multiplied to the 24x squared. So it's correct that way. And when we add them give us negative 11x. It makes no difference where we place the negative 3x and the negative 8x into the grid. Looking in the top line, we see that x is the highest common factor. X by 2x gives us 2x squared. X by negative 3 gives negative 3x. Negative 3 into 12 goes negative 4 times, and we see that negative 4 by 2x is also negative 8x. So that works. So we can say the factors of this quadratic is 2x minus 3 and x minus 4. And these are the last two examples. So we're asked to factorize 8x squared plus 10x minus 3. Again, we know that the 8x squared goes in the first box, the negative 3 goes in the opposite corner of the diagonal. When we multiply this diagonal, we get the same as the other diagonal, and we get negative 24x squared. That's negative 3 by 8x squared. We want this to add up to plus 10x. So we're thinking of factors of negative 24x squared that add to 10x. We know the signs must be different in these, but the positive number is bigger. So we're thinking maybe if we have 12x and we take away 2x, it adds to 10x, but it multiplies to negative 24x squared. It makes no difference where we put the 12x and the negative 2x into the grid. We're thinking of the highest common factor in the top row. We see that 4x goes into both terms. 4x by 2x gives us 8x squared. 4x by 3 gives us 12x. 3 by negative 1 gives us negative 3, and we see that this works because negative 1 by 2x gives us negative 2x. So we'd write out our factors then in brackets. We have 2x plus 3 times 4x minus 1. And the final example in this video, we're asked to factorize 7x squared minus 19xy minus 6y squared. Again, we're going to use the quadratic array, the first term in the first box, the final term in the opposite diagonal. If we multiply the two of these, we get negative 42x squared y squared. we know that the missing diagonal has to add up to negative 19xy, but it has to multiply to negative 42x squared y squared. So we're thinking of factors of negative 42. We know that it'll have to be positive and negative, and we know them both must be xy terms. So we're thinking the negative is larger than the positive. So I'm thinking negative 21 by positive 2. If we multiply them, we get the negative 42. With adding them, we get the negative 19. So these are the factors that work. It makes no difference where we place each factor into the grid. Looking along the top row of the grid, we see the highest common factor is 7x. 7x by x gives us 7x squared. 7x by negative 3y gives us negative 21y xy. And negative 3y multiplied by 2y gives us 6y squared. Also 2y by x gives us 2xy. So we write out our factors as x minus 3y by 7x plus 2y.